For question 10, we have a straight current carrying conductor, right, wire Y, creating a B field, and wire X is lying perpendicular to this wire Y. So we are supposed to find out, right, what is the magnetic force on different parts of this wire X. To first solve, right, you must ask, what is the B field like around wire Y? So we know that the wire, the B field, right, around this wire must be concentric circles. But P, Q, and R are all at different distance and so many points. So we don't want to draw too many concentric circles. Instead, right, we know that any point on the circle, right, the direction is actually simply the tangent. Okay, so we can actually, right, just represent it quite simply. First, by drawing a line connecting the wire Y to that point. So for P, right, it's very straightforward. By the way, the direction for here is anti-clockwise. So for P, right, the B field is this way. So B field at Q is this way. Yeah, just say P. I meant Q. So B field at Q at this way. What about for P? For P, right, you draw a line connecting. So this is like a radius. So what's the tangent? Tangent will be like this. So this is the B field at point P. Similarly, at R, the B field, right, will be this way. So the current, right, at P, right, is this short segment. Okay, so you can think about P as a short segment of the wire, and the current is to the right, okay, relative to the B field. Or rather, you can think about B field as generally downwards, relative to the current. So with this, right, you can predict the force at point P will be out of the paper. Into the paper. Use Fleming left-hand rule. So your index finger point down, your middle finger point to the right. So the force at point P will be like this. Force at point R, you see, current is generally to the right, but B field is generally upwards. So apply Fleming left-hand rule. The force at point R will be this way. Okay. Force at Q, no need to do anything, it's zero, because the wire is parallel to the magnetic field. Okay, so let's read through the statement to see which one is correct. Magnetic field at P is opposite direction to R, so that's actually the correct answer already. Okay, so answer is A. B force at P is out of the page, incorrect, it's into the page. Magnetic field at Q is the largest because it's the nearest. The force is the largest. The field is the largest, but the force is not. Okay, because there's no force. The wire is parallel to the wire, so this one is false. Lastly, no B force acting on wire at all 3 points because they are perpendicular. Well, the correct answer is, right, there's no net force. No net force because perpendicular, but there is individual forces at different points. So this statement is also wrong. So by the way, right, why is it that this statement is phrased this way? It's because, right, we know light current attract, okay, and light repel. So these are for what? These are for parallel wire. So for parallel wires, right, they actually have a force on each other. Yeah. For perpendicular wire, right, there's actually no net force. But is there a force at different parts? There is. Is there a net effect? There is also. Okay, there will be a moment. The moment, right, will be trying to align these two wires. So you see, now, right, you have on this wire X, right, on the P side, it's going to flip downwards into the page. On the R side, it will be flipped upwards. So this entire wire, right, will try to flip itself to become same direction as wire Y, with the current flowing in the same way. Okay, So in a parallel situation, right, it will tend to flip towards the light current case. Yeah. But anyway, this is just extra info.